Hello, my dear friend. Today we will see what an insertion sort is. We will use an example to see how it works. Also, we will implement the algorithm on this whiteboard. Let's take an example array. We have 5 elements in this array. This is an unsorted array. You can see the elements are not arranged in ascending order. In order to understand what an insertion sort is, you have to understand how to insert an element to this array. While doing insertion sort, we consider the first element in the array is already sorted. Insertion sort simply means inserting an additional element to an already sorted array. But it is not already sorted. So what will you do? In order to do the insertion sort, you must first understand how to do an insertion into an already sorted array. So for that, we will take a smaller example. So this is an array which has 3 elements, 2, 7 and 9. If you want to insert a number, say 5, where will you insert? You will insert in this position, right? But how did you find it? You did something step by step, right? You compared 5 with 2. Yes, 5 is greater, so it comes after 2. Then you compared 5 with 7, and it is 7 is bigger, so 5 comes before 7. So you understood that it should come between 2 and 7. But here we don't have space to insert 5 in that position. So what will we do? So we will just move the elements one position ahead to create space for our 5 to be inserted. So now we have 2, 9 comes here, 7 comes here, and we have 5 here. So 9 is copied here, 7 is copied here. So you have 2 7s. So in the first 7, you will replace it with 5. Already we are doing a swapping. So why should we compare from front to back initially? Instead, we can swap and compare together. So how do we do that? We will take the same example. We have 2, 7, 9. Okay. Here we have space, but we don't have anything there. So instead of comparing 5 with 2 initially and understanding where to put it, we will compare from the back so that we can swap in the same comparison. So we compare 5 with 9. 9 is bigger, so swap once and create space for 5. Now we compare 5 with 7. 7 is bigger, so we swap 7 to the next place. Now we compare 5 with 2. 2 is smaller, so we shouldn't swap 2. We just have to update this with 5. So already we have 9 here and we have 7 here. Whenever the number is bigger than the number we are trying to insert, we copy it one position ahead and create a space for the element to be inserted. We do this until we found the right position for our element to be inserted and we insert it there. It's as simple as that. So how do we use this for sorting, which doesn't have elements already sorted partially? For that, we will go one at a time. By one at a time, I mean in each pass, we will consider the number of elements sorted increases. In every subsequent pass we go through this array, we will get one more element sorted in the array. So I will tell you what it means. Consider the first element is already sorted. I know it is not sorted, but why I say the first element is sorted is when you have only one element in an array, it's already sorted. We consider this first element is already sorted and it is an array of size 1. And during every pass we are going to insert one new element to this sorted array in the right order, like we did in that example. So here what can we do? We will compare this element with 23. 3 is smaller than 23. So what will we do to insert 3 there? We will copy it one position ahead, create space for 3, and then we will insert 3. So after this pass, it will look like 3, 23, 45, 32, 2. Now we have 2 elements sorted. Now we are going to insert this 45 into this sorted array. So we will check 23 and 45. 45 is already bigger, so we don't have to create space for anything. It is already in its right place. In the next pass, now we have 3 elements sorted. Now in the next pass we compare 32 with 45. 32 is smaller, so we move 45 one place ahead to create space for 32. Now we compare 32 with 23. 23 is smaller, it's not bigger than 32, so we will insert it here. So the resulting array will look like 3, 23, 32, 45 and 2. Now we have 4 elements already sorted in this array. Now we do a similar comparison for 2. 45 and 2. 45 is bigger, so we copy it here. 2 and 32. 32 is bigger, so we copy it here. 2 and 23. 23 is bigger, so we copy it here. 2 and 3. 3 is bigger, so we copy it here. Now we have created space here where we will put this 2 here. So the resulting array is 2, 3, 23, 32, 45. So this is the final array. So you got a sorted array by inserting one element at a time to an already sorted array. First there was this 23 which is already sorted, then we inserted 3 into that particular array and we made a sorted array which has 2 elements. Then we brought in 45 inside that array, which made a 3 element sorted array. Then we brought in 32, which made a 4 element sorted array. Finally we brought in 2 to get the whole array sorted. So as you notice this, in every pass we are creating a sorted array in the left side. Can we implement this in code? Definitely. Let's do it. We pass the array that is to be sorted, and also we will pass the number of elements. In some languages you do not need the number of elements to be passed, as you can find that from the array itself. One thing we have to focus is we have to have an example ready so that we can write the code easily. 2, 3, 7, 9 and 5. Consider this part of the array is already sorted. We have to insert this element to the right position. So here I is, here the index is last. 0, 1, 2, 3, 4. Here the index is 4. So every time we are going to insert 5 to the right position in this array. So since we will be overwriting this position, we will take it as a separate variable x equal to 5. Then we will compare x with 9. 9 is bigger, so we will copy it here. 7 is bigger, so we will copy it here. 3 is smaller, we don't copy it, but we have created a space here where we will put the 5. If you remember, we started with the first element already sorted. So we have to start from the second element of the array only. We don't want the 0th index to be checked. Int I, comma j for I equal to 1, I less than n, I plus plus. In every pass, we will insert one element to the already sorted array. Now we will copy that element to a separate variable, like we copied 5 here. We want another variable x. X is equal to arr of I. Now we move to the insertion phase. In insertion phase, what will we do? We will start from this position till it finds an element that is less than the x. So this we will consider it as j. So j starts from I minus 1. J equal to I minus 1. J greater than, till what position we will go? We will go till the 0th position to insert. Greater than or equal to 0, j minus minus. What are we going to do here? We are going to copy one element at a time to its next position if it is bigger. If arr of j is greater than x, since 9 is greater than 5, we copied it to the next position. Arr of next position means j plus 1 equal to arr of j. If it is smaller, what will we do? We will insert in the right position. But inserting in the right position, we will not do in the else condition, because we have an edge case that will not be satisfied if we do this here. So we will just come out of the loop and then we will copy x to that position. Arr of j plus 1 equal to x. Why did I use j plus 1? Because every time we are inserting in j plus 1 only. Every time we are copying to j plus 1 only. So this was j plus 1 initially, we copied 9 here. This was j plus 1, so we copied 7 here. Now when we hit a place where it is smaller, now also we will copy the new element x to j plus 1. So every time we are inserting in, we are either overwriting in a position or we are inserting in a position that is next to the position that we are comparing. We are comparing 3 and 5, but we are inserting it in the position of 7. So this is j. The comparison is between j and x, but the insertion is in j plus 1. What edge case did this satisfy? We could have put it here also, right, before the break. That is because if it is the smallest element, say the smallest element is the next element that we are going to insert is 1. Okay, so we will write it here 2, 3, 5, 7, 9. In this array, we are going to insert 1. So it has to go till this position. J will be 0. That time also J is 2 is larger, so 2 will be copied here. As we copied all these elements here, 2 will also be copied in the same way to here, and j becomes minus 1, and it will come out of this loop. So that time j is minus 1, so we insert the element in j plus 1, which is 0, 0th position, which is 0th position. I'll go through it once. We started from the first position because the 0th position we consider it as already sorted array. We go till the last element to insert it into the sorted array. We will take the element in the current position into x. Then we go from I minus 1 till 0th position, where we compare the current element with x. If it is bigger than x, we move the current element by 1 position ahead. If not, in that created space, we will insert x. Do you know one interesting thing? Insertion sort is the most efficient algorithm when the array size is small. I hope you understood the insertion sort algorithm well. Instead of telling you how an algorithm works, this guide tells you when to use it. Do you find yourself wondering which data structure or algorithm to use in a particular situation? Then this guide is definitely for you. Grab the guide by clicking the link in the description. Until we meet the next time, this is Shivakumar aka Algo Shiva signing off. Bye.